Now we're on Chapter 1, Lesson 11, Evaluate Numerical Expressions, where we write and interpret numerical expressions. Evaluate means to solve. So in the lesson prior to this, we were creating these equations, we were writing the numerical expression out, and now we're evaluating and solving them. Before we could evaluate and solve numerical expressions, we have to know that there is a rhyme and reason to what we do, meaning a lot of grown-ups will say PEMDAS. Now, PEMDAS is an acronym, and the P stands for the parentheses. The E is the exponent. So, like, let's say we had 10 to the second. It's that small 2 up here, the power of the exponent. M stands for multiplication. D stands for division. A stands for addition. And S stands for subtraction. So first, we have to remember the order of PEMDAS, where P stands for parentheses, E stands for exponent, M stands for multiplication, D stands for division, A stands for addition, and S stands for subtraction. Then we have to know, we will always have to do the parentheses first. After the parentheses, no matter what happens in the equation, if you see a parentheses or the expression, you'll do the parentheses first. Then we will do the exponents, followed by multiplication or division left to right. Now, even though the M goes before the D in PEMDAS, we will multiply or divide, whichever one comes first, going left to right. And then last but not least, we will do the additions and subtractions. So before we actually jump into the problems that you'll see on the paper, let me show you what that might look like. So let's do 20 plus 5 times 2. So if you look at this, you're going to have to do, if there are any parentheses, we're going to do it first. So over in this expression, 20 plus parentheses 5 times 2, there is a parentheses. So you're going to do the 5 times 2 first. So we're going to copy everything else. All of this stays the same, the 20 plus. And the only thing we're going to solve is the 5 times 2. So the parentheses first. 5 times 2 is 10. So you could see that all we did in the expression so far was just the parentheses. 5 times 2 is 10. Everything else stayed the same. And now there's nothing else left to do but the addition. 20 plus 10 is now 30. And that's all we're going to be doing. We're going to say, are there parentheses? If so, we do it first. If not, we move on. Are there exponents? If so, we do that first. If not, we move on. Is there any multiplication or division? If so, we'll do it left to right and before moving on. And then is there any addition or subtraction? We'll do that going left to right. So let's jump into the actual unit now. And let's rewrite PEMDAS on the top here so we could remember. P, E, M, D, A, S. And let's, so we don't forget, put parentheses on top of the P. Do a small exponent to show the exponent. Multiplication, division, addition, subtraction. And once you have your cheat sheet out, you'll write, first thing we do, we'll do parentheses. The second thing we'll do would be exponents. The third thing we do would be multiply or divide left to right, whichever one comes first. If there's a division first, we'll do division. If there's a multiplication first, we'll do multiplication. And last but not least, we'll do the addition or subtraction. So, I'm going to rewrite this because they have kind of some work shown already here. 24 times 5 minus 41. And imagine that their work wasn't shown yet. You're going to ask yourself, in this numerical expression, numerical meaning numbers and expression meaning this right here, are there any parentheses? Because that's the first step. Yes or no? I do not see any parentheses, so we move on. Step number 2, we're now looking for exponents. Do you see any exponents? I do not, so we're moving on. Then we're going to multiply or divide, whichever one comes first, left to right. Do you see any multiplication or division going from left to right? I see 1. And so what I'm going to do is I'm going to underline this section, or you could square that section and say, I'm going to do this first. I'm going to do 24 times 5 And if I don't know 24 times 5, I could do on the side here. 5 times 4 is 5, 10, 15, 20. I'm going to regroup the 2. So there's my 20. 5 times 2 is 5, 10, plus 2, 11, 12. It's 120. So that's where they got this 120 right here. 24 times 5 is 120. Now once you do the 24 times 5 and solve the 120, you write the rest of the expression out, minus 41. And here, there's no other thing. There's no parentheses, there's no exponents, there's no multiplication or division, and the last thing we have to do is subtract these two numbers. And so now all we do is 120 minus 41. Now 0 minus 1 you can do technically, but you'll end up with a negative number. So for this, we're going to regroup. We're going to get a 2 from the tens place and turn that into a 1. And we're going to regroup the 0 into 10. 10 minus 1 is 9. 1 minus 4 you could technically do, but it will be a negative number. So instead we're going to regroup and borrow from the hundreds. That will become a 0. And this 1 will become an 11. And it's going to be 11 tens. 11 minus 4 is 1, 2, 3, 4. It's 7. And so for their final answer they have 79. Let's do number 2 because I'm going to be very specific here. You're going to have to draw boxes on each step that you're going to do. So I know you're not making it up. You have to make sure you go in order. So for this first one, you're going to see, are there parentheses? If so, we're going to box it and do just the parentheses. So do you see any parentheses? I do, and it's right here. So the first thing we're going to do is 32 minus 20. If you can't do 32 minus 20 in your head, you could do it on the side. 32 minus 20, 2 minus 0 is 2, 3 minus 2 is 1. So 32 minus 20 is 12. So for this box, it becomes a 12, and we're going to write the rest out, divided by 4. This divided by 4. Now, there are no more parentheses, there are no exponents, but there is a multiplication or division. It's division. 12 divided by 4. And if you don't know 12 divided by 4, you could say, what times 4 is 12? 4, 8, 12 is 3. So our answer is 3. 3. So you're going to keep showing your work. The thing I'm going to be looking for full credit is that you do box your steps out. So one step at a time, either the parentheses, the exponent, multiplication, division, addition, or subtraction in that order. And do only one step at a time. So here you could see we have 1, 2, 3 lines, 1, 2, 3 lines of work. And so I want to be able to see, here you're going to be needing 4 lines of work because there's 4 digits. I want to be able to see your process. Number 9, 10, and 11 is almost like a puzzle. And if you know anything about me, you know that Miss Tolentino loves puzzles. And so this is like a game, and actually this is a game I used to play in 5th grade when I was your age, where we rewrite the expression with parentheses to equal the given value. What they're saying here is if you solve this right now, you won't get 11. And let's try it out. Let me take a scratch paper just to prove that to you. So right now, it says 3 times 4 minus 1 plus 2. So they're saying 3 times 4 minus 1 plus 2. If we were to use PEMDAS, you'll see that there are no parentheses, there are no exponents. So the first thing we're going to do is multiply or divide left to right. I see a multiplication here, so we're going to multiply this. 3 times 4 is 12, and then you're going to write everything else out. Subtract 1 plus 2. After we do that, we're going to look for any more multiplication or division. I don't see any more multiplication or division. So we're going to add and subtract left to right. So the next one we do is 12 minus 1. 12 minus 1 is 11. And then add the 2. And last but not least, 11 plus 2 is 13. Now you can see here, if you straight up do 3 times 4 minus 1 plus 2 without any parentheses, your answer is 13. What they want you to do is get the answer of 11. So they want you to add parentheses somewhere. So let's rewrite that. 3 times 4 minus 1 plus 2. Now you may or may not know where to put the parentheses, so try something. Let's try putting the parentheses around the 1 and the 2. Let's see what happens. 3 times, nope, I did it wrong. First you need to look for parentheses, so you're going to do the 1 plus 2 first. So you have 3 times 4 minus, what is 1 plus 2? 1 plus 2 is 3. After that, there are no more parentheses, so we're going to do exponents. I don't see any. Then we'll do multiplication or division. Oop, I found a multiplication. We're going to do 3 times 4 is 12, and then minus 3. Last but not least, 12 minus 3 is 9. We want the answer to be 11, so this is still the wrong answer. So let's try putting the parentheses somewhere else. All right, we have 3 times 4 minus 1 plus 2. We tried putting it around the 1 and the 2. We tried doing the 3 times the 4 first, and that didn't work. What happens if we put the parentheses at the 4 and at the 1? Let's see. According to PEMDAS, we have to do the parentheses first. We have to do 4 minus 1 first. So it would be 3 times 4 minus 1 is 3 plus 2. So you see how we're just copying everything. There's a 3 times the 2, there's the plus 2, and all we did was solve 4 minus 1 is 3. Now the next thing in PEMDAS is, are there any more parentheses? No. Are there any exponents? No. Is there any multiplication or division? I see a multiplication. 3 times 3 is 9 plus 2. And then last but not least, we just have to add. 9 plus 2 is 11. That is our final answer. So our final answer is 3 times parentheses 4 minus 1 plus 2. And we could show our work by doing the 4 minus 1 first. 4 minus 1 is 3, so 3 times 3 plus 2. The next step in PEMDAS, after the parentheses are exponents, there are none, so we do the multiplication. 3 times 3 is 9 plus 2. And last but not least, we have our addition, which is 11. So our final answer is 3 times parentheses 4 minus 1 plus 2. And you could see that the only way to solve this is kind of to play with the numbers. You could try doing it without parentheses and see where it takes you. We got 13. We could try putting the parentheses between the 1 and the 2, see where it takes us. We got 9. And then we tried putting the parentheses on the 4 and 1, and we got 11. So for 10 and 11, try putting the parentheses in different places until you get the answer of 4. Try putting the parentheses in different places until you get the answer of 10. And it's going to be a game. It's going to be guess and check. You could do what I did, which was use a scratch paper to try the different answers, but on your actual homework, only put the correct answer down. Or you could try seeing if you could fit everything on here. But I personally would use a scratch paper, aka your math journal, so it's organized, to do that. But whatever floats your boat. Let's go look at the problem solving. My favorite, is word problems. Have fun with 10 and 11. This is where it's like a puzzle. I like it. Okay. Sandy has several pitchers to hold lemonade for the school bake sale. 2 pitchers can hold 64 ounces each, and 4 pitchers can hold 48 ounces each. How many total ounces can Sandy's pitchers hold? So here, we need to solve the answer. So in lesson 1-10, we were just writing the expression out. Now we're writing the expression and solving it. So let's do a part whole for this. Because I don't want to use any more scratch paper, I'm just going to write on here. That's okay. And what's happening to this lady, Sandy, is she's having a school bake sale. So she's trying to make a profit. And the way she's going to make her profit is by selling lemonade, so selling drinks. She has a ton of pitchers. She has 2 pitchers that can hold 64 ounces each, and she has 4 pitchers that can hold 48 ounces each. And we want to find out how many total ounces can Sandy's pitchers hold. So just looking at this, I can already tell, based on the fact that they want us to find the total ounces, that our X's we don't know. The X is up here. It's the total ounces Sandy's pitchers holds. How many pitchers does she have? She has 2 pitchers and 4 pitchers. All 6 pitchers hold. Now we have to go to the picture box. You have to ask yourself, what does one box represent? And it's not that easy, because either we're going to have 64 boxes or 48 boxes or whatnot. Think about it. What does one box represent? In this specific scenario, it represents 1 pitcher. So there's 1 pitcher that holds 64 ounces. OZ stands for ounces. And you have 2 of those pitchers. So that's 1 pitcher. That's 2 pitchers. 1, 2 pitchers. 2 pitchers hold 64 ounces. So that's this picture right here. 2 pitchers can hold 64 ounces each. 1 pitcher, 2 pitchers, 64 ounces, 64 ounces. Then you have 4 pitchers. I'm going to use a different color for this because it's a different amount. Then I have 4 pitchers. I have 1 pitcher of a different amount, 2 pitchers, 3 pitchers, 4 pitchers, and these 4 pitchers only hold 48 ounces, so this holds a little less. So there's 48 ounces, 48 ounces, 48 ounces, 48 ounces. So let's read through this again and see where the pictures are coming from. Sandy has several pitchers to hold lemonade for the school bake sale. You can see them down here. 2 pitchers hold 64 ounces each. 1, 2 hold 64 each. 4 pitchers can hold 48 ounces each. 1, 2, 3, 4 hold 48 ounces each. How many total ounces can Sandy's pitchers hold? So X is the total one that all 6 hold. So you could either do 64 plus 64 plus 48 plus 48 plus 48 plus 48. And you could do that on the side. Do 64, 64, 48, 48, 4 times 48, 48, and you could add that up. Because we're in the multiplication problem and the multiplication section, what I would do would be, we repeated 64 twice. So that's 64 times 2. And you're going to add that to, we repeated 48 4 times. 48 times 4. And so what I would rather do would do 64 times 2, figure this one out, 48 times 4, and then add these 2 together. Now from here on, you're going to solve the rest of it. So if you want, you could pause the video as I move on to number 13. But have fun solving that one. I hope that helps. Here's another bake sale, and instead of Sandy, it's Jonah. At the bake sale, Jonah sold 4 cakes for $8 each and 36 muffins for $2 each. What was the total amount in dollars that Jonah received from these sales? Here's another selling one. Now what we're selling is different, but the items that we're selling will be what's for each box. So we're at the bake sale again, and in order to make a profit, Jonah is selling 4 cakes for $8 each and 36 muffins for $2 each. What was the total amount in dollars that Jonah received from these sales? What was means that you don't know. So that's your variable, that's your X that you're trying to find out. And we're trying to find the total amount in dollars Jonah received from the sales. So that's what's going to go on top, because the total goes on top and you don't know it. X equals the total dollars Jonah received from, and instead of saying these sales, I'm going to be saying from cakes and muffins, because those are the things he sold. So the X is the total dollars that Jonah received from selling both cakes and muffins, because those are the 2 things he sold. I'm going to use 2 colors like I did last time. I have 4 cakes for $8 each. So how's that going to look? One box is going to represent 1 cake, 2 cakes, 3 cakes, 4 cakes, and inside is $8 each. 8, 8, 8, 8. Furthermore, he has 36 muffins. 1 muffin, 2 muffins, 3 muffins. Now, I'm not going to draw 36 muffins out, so I'm going to draw an arrow and say, hey, this is my 36th muffin. And in each one, there's $2. Muffins are a lot cheaper than the cakes, huh? Now, from here, you could either do 8 plus 8 plus 8 plus 8 4 times, then 2 plus 2 plus 2 plus 2 until you added 2 36 times, or you could multiply. And what I'm going to do is I'm going to let you try to think if you could come up with your own equation similar to down here for this, your own expression, and to be able to solve it. But I know that when I'm drawing the picture boxes, I already know what the boxes should be and what should go inside the box. I want to tell you that it's natural, it's normal if it's hard for you to decide. It might take time, but you have to think it through. What will make sense? What is being repeated? What does the box stand for? And so if you find yourself, staring at it, trying to figure out the numbers, that's fine. Play with it. You might not always get it right the first time like I do, and how I could do 1C, 2C, 3C, 4C very easily to stand for the cakes. You might have put your $8 down here instead and then, messed it up. That's okay, as long as while you're writing it down, you're like, oh, that doesn't make sense. And the second it doesn't make sense to you, you got to start thinking, hey, are the numbers in the right spot? Because if not, I got to change it. And so don't be afraid to be frustrated enough to say, hey, I got to think about this. And don't be afraid of the challenge, because I know that I make it look pretty simple, but it's not as simple as I make it look. You really have to sit down and think for a second, and the only reason why it's so simple for me is because I've been doing it for so long. All right, so don't give up. Make sure to persevere. Make sure to attend to precision, and have a good day.